Welcome to my YouTube channel. So today I will discuss after what I have discussed in system of linear equations. So this is lecture 3. So if you didn't watch lecture 1 and 2, first you have to watch the two videos. So after that you watch this one. So in the previous lecture I have discussed when there is a unique solution, no solution, infinite number of solutions of a system of two linear equations mathematically. So now I will show graphically. First you have to know if there is two equations, that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2, then first this equation number 1 and equation number 2. First is equation 1 and equation 2 will intersect at only one point if this ratio a1 by a2 equal to b1 by b2 not equal to this, if not equal to this. So if slope of this equation and slope of these equations are different, then we say that these two lines are cut at exactly one point. So like this, if this is the equation line and this is the line, so their slope are different. For this line this is slope, and for this line this is the slope. Slope means the positive angle with x-axis. So for this line, two line, they intersect exactly at one point. So whenever you are given a system of two equations like this, you can find graphically. First check a1 by a2, b1 by b2. If these two are not equal, then you simply say that this system of two equations has exactly one solution, that is unique solution. Okay. So these results come from the slope. Slope means you know if this is equation and this is the theta angle with positive x-axis, then a equation y equal to mx plus c, where m equal to is tan theta, this is called slope, and this is c, which is called, this is y-axis, so c is called y intercept. This is called, c is called y-intercept, and here m is called slope of this line. So for this line we get slope is minus a1 by b1, and for this line slope will be minus a2 by b2. So this will be different if this quantity will be not equal. So these two ratios. So from that we get, whenever this happen, so we say the system has exactly one, that is unique solution. And we will give example for each case. And secondly, equation 1 and equation 2 will be parallel if a1 by a2 equal to b1 by b2 but not equal to c1 by c2. That is, if the slope of this equation are same but the y-intercepts for these two lines are different, then this will happen. And whenever this happen, these two equations will be parallel. So whenever these two equations will be parallel, so like this, so for both this angle will be same, but y-intercept for this line, y-intercept will be this negative, and for this line y-intercept will be this. So y-intercepts are different for two parallel lines, and the slopes are equal. So then this line will be parallel, and there exists no such point at which these two lines are intersects. So that's why whenever you are given two parallel line in a system, then the system will have no solutions. And the third case, equation 1. Equation 1 means line 1, line 2. Okay, line 1, line 2. Equation 1 and equation 2. So you can write line 1, and these are equation of line, and line 2 will coincide each other if a1 by a2 equal to b1 by b2 equal to c1 by c2. If slopes and y-intercepts for these two lines are equal, then these lines will be coincide. That is, if this is the first line, then on this line second line will be there. So in that case, each point is a intersect point between these two lines, therefore each point on this line will be solution, and in that case the system with these two equations, that is coincide equations, have infinite number of solutions. So let us take some examples. First, we take unique case, that is unique solution exists for this system of two linear equations. So if you compare these two lines with y equal to mx plus c, so from this equation we get y equal to x plus 1, and from this second equation we will get y equal to 12 minus 3x divided by 2, that is minus 3 by 2 x plus 4. So that is, if we draw these two lines, so this will be 1, so 45-degree angle, and y will be 1, positive 1. So this is like this, and this will be negative but for positive. So this was minus 1. This was minus 1. Let us take another case. So whenever you draw a line, you take the line in this form. It will be easier to draw. So whenever this line, the line will intersect x-axis at a comma 0 point and y-axis at 0 comma b point. So this will be a comma 0 and this will be 0 comma b. So this line will be like this. So if we put first line in this form, therefore we get x by minus 1 and this will be plus y by 1 equal to 1 by dividing minus on both sides. So therefore this equation will be, it will cut at minus 1 comma 0 and y-axis at 0. This will like this. So this is first equation, and if we put this as x by 12 minus 3, that is 4, and plus y by 6 equal to 1. So x at 4 comma 0 and y at 0 comma 6. So like this. So this will be this line. So these lines cut exactly one point. So this system of two equations will have unique solutions. So this is from graph, and also these two lines have different slope, as you can see from this line. That is, if you compare, if you find a1 by a2 and b1 by b2, so you can find this a1 is 1, a2 is 3, and b1 is minus 1, b2 is 2. So these are not equal. So from this also you can find that these two lines have different slope. So this is theta 1, this is theta 2. So if you put in this form, you can draw the line easily, and from that picture you can find the nature of the solution. So in this case the solution will be unique. So now we discuss no solution. So from this, if you find a1 by a2 and b1 by b2, so you will get 1 by 2, 1 by 2, and this will be 3 by 6, that is nothing but 1 by 2. So this will be equal, this will be equal. But c1 by c2 is 3 by minus 8, so that is not equal to c1 by c2. So this will satisfy the second case. So in that case, these two lines L1 and L2 are parallel. So therefore this system of equations has no solution. So if you draw this line, these two lines, you will get x by 3 plus y by 1 equal to 1. So this line will cut x-axis at 3 comma 0, y-axis at 1. So if we draw this, this will be the line, and the second line will be same as x by minus 8 by 2 plus y by minus 8 by 6 equal to 1. So like this, these are negative. So this will be here divided by 4. So 8 by 4 like this. So this line will be like this. So this will be parallel. Okay? So these two lines are parallel. So therefore system with these two equations will have no solutions. So you can see in this equation, just observing these two equations, you can say that this system of two equations has no solution. Simply this left hand side of this equation, so left hand side of L2 is 2 into left side of L1, but the right hand side you will get not equal. So if you take 2L1, you will get the left hand side of L2, but you did not get, so you will not getting the right hand side of L2. Okay. So if you multiply L1 with 2, you will get 2x plus 6y, and this will be 6. But in this equation there is a minus 8. So from this you can say that these two equations has same slope but different y-intercepts. So if you assume that these equations of line, so from this you will get for these two lines this c constant term will be different. Okay. So from that we can say these two lines are parallel. So whenever the line is parallel, this means simply, so let us take any two parallel line. So this is L1 and this is L2. So whenever you take parallel lines, so similar, you can see these two angles are same, that is slopes are same, but y-intercept, that is for this L1 y-intercept this C1, and for this L2 y-intercept is this C2. Okay? So whenever two lines are parallel, they have same slopes but different y-intercepts. That's it. And last case, so now we discuss the infinitely many solution case. So these two equations are given. So from these two equations, you can find a1 by a2, that will be 1 by 2, b1 by b2, that will be 2 by 4, and c1 by c2, that will be 4 by 8. So this is also 1 by 2, this is also 1 by 2. So therefore these are equal for this two equation. That is, slope of these equations are equal and the y-intercepts are also equal. Okay? So that is, these two lines are same, that is coincide on each other. Okay? So each point on this line will be the solution for the system with these two equations. You can see in these two equations, if you find 2L1, you will get 2x plus 4y equal to 8, which is exactly equal to the L2. That's why this case happened. So in the infinitely many solutions case, so in a system, whenever you are given a system of linear equations, and there is two equations, which is one is multiple of others, that is here L2 is nothing but 2L1. So in that case, so whenever this case happen, so this system will have infinite number of solutions. So in the previous lecture I have discussed system of linear equations in triangular form. So whenever we find or we can write a system of equations in this form, that is the coefficient matrix will be like this. The each element below the diagonal element are all 0, then the system is called triangular matrix. So in that case, finding solutions for the system will be very easy, or you can find easily. So you can see in the first equation there is, so this is a system of 4 equations with 4 unknowns. 4 unknowns x1, x2, x3, x4, and 4 equations are L1, 2, 3, 4. So in first equation, each coefficients of xi are non-zero. In the second equation, coefficient of x1 is 0. In the second equation, coefficient of x1 and x2 are 0. And in the last equation, coefficients of x1, x2, x3 are 0. So whenever you are given a system of 4 equations and 4 unknown, and if you find the triangular form of the system, that is, you have to make coefficient of x1 is 0 in the second equation, coefficient of x1 and x2 0 in the third equation, and coefficients of x1, x2, x3 0 in the fourth equation, then you will get triangular form, and therefore you easily can find the solution of the system. As you can see from this, you can find x4, which is equal to 4, and by putting x4 in this equation 3, you will get x3, so which will be equal to 1, and by putting these two value in this equation, that is x3, x4, if you put in this equation 2, you will get x2, and by putting x2, x3, x4 in the first equation, you will get x1. So this will be minus 2, and this will be 3. So you can easily find the solution whenever the system are given in triangular form. So our main aim will be write a system of linear equations in triangular form, and to do that we will use some operations that is called elementary operations. So by elementary operations we can make triangular form of a system of linear equations. So we will discuss that. That's it. If you like it, please subscribe my channel and share with your friends. So it will be very beneficial for the students of Technology Bhagalpur, first year students who are dealing with the course MA 101. You all will be benefited by this lecture. So thank you very much.